Hello and welcome back to chemistry. So today we're going to finish module 4. We're going to do a tiny bit of review before you do experiment 4.4. So let's review a tiny bit. Page 112. Please remember the different phases of matter or states of matter. That's another name that we can give. States or phases of matter. So we have solids, liquids, and gases. You need to know very well the difference between them. So atoms or molecules, very tightly compacted, very orderly. They're vibrating. They have a tiny bit of energy and vibrate. Solid. Liquid, more energy. There's more disorder because they're moving a tiny bit faster. They are less tinily compacted than solids, but more tinily compacted than gases. Okay? And there are forces keeping those atoms or molecules together. Gases, atoms or molecules with a lot of energy, moving very fast, and it's very disorderly, collisions everywhere, and if they can, they will escape the container you want to try to keep them in. So know this. Know that the forces that keeps the atoms and molecules in a solid are very strong. In liquids, they're strong. But in gases, keeping it together are very weak. That's why they can move far apart from one another. Kinetic energy, we're going to review that because you really need to know what kinetic energy is. It's going to appear again later in a different module. But kinetic energy, remember, is energy of movement. So is there any movement? Are they moving? They have kinetic energy. They're vibrating, so very low kinetic energy. Then low for liquids and gases high. And you need to be able to compare everything. Particle motion, vibrate and rotate about a fixed position, slide over each other, and move about at great speeds. So this is review. We also talked about volume. Do you remember what we said about volume for each one of them? Think for a second before I tell you, because you need to be able to do that too. Okay? You need to be able to tell me what's going on with the volume. Well, as you move this way and you move this way, you're increasing the kinetic energy, meaning those atoms and molecules can move farther apart from each other. You are increasing the volume. Okay? So what does it mean about density? What is density? The amount of mass divided by the volume they occupy, if you remember that. So gases are less dense than solids for most substances. And we're going to see in a minute there are exceptions to that rule. But you know that most solids will sink inside their liquid. So you have a solid of iron and liquid iron, and you place the solid iron inside the liquid iron, it will sink because it's more dense than liquid. Okay, now let's review the kinetic theory of matter. Very important for you to know this. It's going to be on your test. Molecules and atoms are in constant motion, and the higher the temperature, the greater the speed. That's what this theory says. You already know that all, let me see if I can move this out of the way. All matter is made up of tiny little particles. Those can be atoms or molecules. They are always moving, vibrating, moving a tiny bit faster or a lot more fast, depending if it's solid, liquid, or gas. And the temperature translates in a back way of looking at heat, which is kinetic energy. So as you increase the temperature, that means there was more heat, more kinetic energy, means more speed for those particles. And here it is. Higher temperature equals faster moving, more energy. Lower temperature, slower moving because they have less energy, less kinetic energy. And this is the same in a compacted way. Up means higher speed if the temperature is also increased. Lower speed if temperature is low. That's all it means. And you're going to see a lot of abbreviated information like this in science. We don't like to write a lot. So we abbreviate a lot of the information with arrows and signs and stuff like that. Now, you will be doing experiment 4.4 this week. It's on page 113, in which you are going to look, well, you know, a lot of the experiments we do is just you proving some of the things you're learning. So in this experiment, you're going to prove the kinetic theory of matter to be correct. Now, water. Water is an exception to the rule in which we said that solids have less volume than liquids. Remember we said that solids usually sink in their liquids and that volume increase as you went from solid to liquid to gas. Okay? Well, water is an exception to that rule. The majority of substances follow that rule, but water is not like that. And that is due to this kind of bonding, hydrogen bonding. We're going to look at another slide that explains the bonding a tiny bit better. But it has to do with the bonding between the molecules of water. So you already know that ice, which is solid, floats in water. Here we have warm water at the top. Cool water is a tiny bit denser. And cool water is denser than warm water because as they have less energy, they are closer together. They are more together and makes it denser, and dense always goes down. Warm water, more energy, they separate. Less dense goes up. But ice, which is a solid, does this, creates these little bonds, hydrogen bonds, that make this lattice, so they expand, and in a way they act like snowshoes. That's what they'll act like. And here we have some hydrogen bonding. So we have two water molecules. That's a representation of a water molecule. And soon you're going to be learning about this little delta negative and delta positive, which just means they have some charges, okay, partial charges. They don't have total charges. You're going to be learning about that when we learn about ionic compounds. But as I said to you before, some molecules develop charges, and charges that are opposite are attracted to one another. So the negative part of a molecule is attracted to the positive part of another water molecule. And they create these hydrogen bonds. And that's what the little dots are. They're just hydrogen bonds. And as you can see, in ice, the hydrogen bonds are as far apart as they can be and make like a big lattice, like a crystalline structure. They're crystalline structures, and they expand. If you expand something, you have more area, okay? You can float, which is what happens to this ice. So they act a tiny bit like snowshoes. There you go. And here, this is a representation of liquid water. They also have hydrogen bonds, but they are constantly breaking and reforming, so they are not creating these very stable structures. Okay, they are moving. Water moves, and as they move, they break the bonds and make new ones. So there you go. Now, I did promise to you that you would have to learn some homonuclear diatomic elements. So those elements that existed in molecular form, not in atomic form, they like to be in groups of two. These are hydrogen, nitrogen, oxygen, fluorine, chlorine, iodine, bromine, and astatine. And they're right here. They're in red in your periodic table. Okay? These are these right here. So all of these atoms in nature, they come in molecular form. They come in groups of two bonded together. So when you are doing chemistry and you need to combine with oxygen, you cannot just put an O, because oxygen does not, in nature, oxygen itself, the gas oxygen, does not exist as just one atom of oxygen. It comes in a pair. So when you're doing chemical reactions, you're going to have to put O2. And you need to know who does that. So you need to study this. You need to study who is a homo. Homo means the same. Nuclear, they have the same nucleus, they have the same element. Diatomics, dia means two atoms. Elements that belong in groups of two that are of the same kind. That's what you're saying. hopefully this makes sense. So memorize them. That when you hear the word hydrogen, you know you have to put H2. That when you hear the word nitrogen, N2. Not inside the molecules. You can see that this is not true. Atoms inside a molecule can be in a group of 1, 2, 3, 4, as many as the molecule needs for that compound. But as an element by itself, so hydrogen by itself is H2. Nitrogen gas by itself is N2. And all of those do the same thing. That's what it makes all of these into homonuclear diatomics. Now, let's start talking about chemical reactions. Let's review a tiny bit. You already know that these little letters represent the different elements in your periodic table, and they are the symbols for the elements. You learned that already. You also learned that when you put atoms together and you're making a molecule and you're making a compound, you are writing a chemical formula for that compound. This is glucose. So instead of writing the word glucose, what you do is put carbon 6, hydrogen 12, oxygen 6. This is the molecule of glucose in chemical form. Oxygen was a homonuclear diatomic. I said to you, when it exists as a gas by itself, you need to put two of them together. That subscript right here tells me that it belongs in a molecule of 2. So carbon dioxide, instead of writing all this long word, you abbreviated that with a chemical formula CO2, water, H2O. So these are your chemical formulas for those compounds. But this, the whole thing together with this arrow in the middle, is a chemical reaction. This one is combining with oxygen, is burning, is combusting. Okay? And you'll learn that the products of combusting are always carbon dioxide and water, but we're going to practice this a lot coming up very, very soon. What you need to know now is that the compounds on this side of the arrow, so not on the pointy side, but before the pointy side, are called the reactants. So the reactants are on this side, on the left side, and you can have one or two or three or four or several. Okay, you're probably not going to do more than 3, I don't think, this year. And everything that's on the other side of the point, right here on the right side of the chemical reaction, is the product. So those two combine to make new things. Products is what you produce out of the reactants. This arrow is red, yields. I don't like to say the word yield, but he does, the author of the book. I just say produces because that's how I learned it. But yield and produce are synonyms, and you can use either one. So what else do you need to know? You already know that's a chemical formula. The little numbers were called subscripts. You remember that from, I think we put that in module 3. Yeah. But anyway, module 3, you learned the word subscript. This tells you how many of each of the atoms you have present. So 6 carbons, 12 hydrogens, 6 oxygens, 2 oxygens, 1 carbon, no number is 1, 2 hydrogens, 1 oxygen. So what are the big numbers in front? If you don't have a number, again, it's a 1, okay? If there's no number in front of a molecule, it's a 1. Those are, in this case, for right now, think about them as a number of molecules. This is a coefficient, and the coefficient can mean a lot of different things. So the big numbers in front of the molecule, that number is called a coefficient, not to be confused with a subscript. Subscript are the little ones, and the coefficient can represent molecules, and later on we're going to learn that it can be, in the case of gases, it can be liters, and something that's called a mold. So you're going to learn what moles are as well. Right now, we're going to talk about molecules. So 1 molecule of glucose combines with 6 molecules of oxygen to yield or produce 6 molecules of carbon dioxide and 6 molecules of water. That's how you read this chemical equation. And you need to know what a reactant is, what a product is, what a subscript is, what a coefficient is. The difference between a symbol versus a formula. So all of that, you need to have it clear in your mind, because when we talk about things from now on, when we do problems, I'll just use those words and you need to know what I'm talking about. So burning coal, that's figure 4.3. You have the burning of carbon at the atomic level. But coal is made out of carbon. That's all it is. Carbon, and is the composition of coal is made out of carbon. So it's the same thing. But basically what we're trying to get at is learning about chemical equations and how they work. So in the burning of coal, burning means combustion. Combustion always implies combining with oxygen, some kind of carbon compound. You have one carbon, represented by this gray ball, combining with oxygen, that is a homonuclear diatomic, so it comes in groups of two, to yield or produce carbon dioxide. So carbon dioxide, for this to happen, everything needs to be broken apart. A chemical reaction is just a rearrangement of the atoms. What comes in must come out. Okay? Matter is not produced. It changes forms, if you remember that. It cannot be destroyed either. It changes forms. So if you're producing something new, carbon dioxide is very different than oxygen and carbon by itself. It's a new compound, a new molecule, a new thing, a new substance, a new behavior, okay? The first thing is to break down everything so they can rearrange themselves. Now, here you have it in chemical form. So that's your balanced chemical equation for the same thing we have right here. And as you can see in your book, he likes to put S's and G's in parentheses. That's the state of the substance. S for solid, G for gas. And I have another slide that has them all. And he likes you to do that, to put in what state all the different parts that are involved in this chemical equation, in what state of matter they exist. Okay? So carbon in the solid form combines with oxygen gas to produce carbon dioxide gas. This is burning, so it's very, very hot. And of course, the carbon dioxide is going to be in gas format. And remember what this was. This was the reactants, and this is your products. This is your subscript. And here, no numbers means you have one carbon combines with one molecule of oxygen to produce one molecule of carbon dioxide. And that's how you read a chemical equation. Now, I said to you that I was going to give you a slide with all the little state symbols. S for solid, L, lowercase l for liquid, G for gas, but you're going to be working with a lot of AQs. What is AQ? Is aqueous solution, meaning a solution in water. A lot of, you already know that life chemistry happens in water, where mostly water, our bodies are made mostly of water, but in chemistry, other kinds of chemistry that's not organic chemistry, a lot of chemistry happens in water solutions. So to show that it was dissolved in water, you're going to put an A and a Q, and that just means aqueous solution. Aqua is the Latin word for water. That's all it is. Now, moving on to figure 4.6, because we're going to be learning about balancing equations. We cannot break the law of mass conservation. What comes in must come out. We cannot have extra atoms floating around. Everything that came in needs to come out as something new. So that process of making sure that everything that comes in comes out is called balancing a chemical equation. And you're going to learn how to do that in this module. Now we're going to practice some more in the next module. But here you have methane. CH4 stands for methane. So that means one carbon, four hydrogens. These together have made methane, the compound methane. Combines with oxygen, so it's burning, combustion, to produce carbon dioxide and water. So here's a representation with circles, and chemistry uses a lot of circles. So there you go. The carbon in the middle, the four hydrogens around, that's methane, combines with oxygen to produce carbon dioxide and water. So let's see what happens here. To produce carbon dioxide, what do you need? You need a carbon. This bubble is a carbon. You put it right here. And you need 2 oxygens. There were 2 oxygens to start with, which you broke apart, and now they are rearranged. This combustion requires you to also produce water. How can we produce water when we don't have more oxygens or more hydrogens? Where are they? We need to produce water. That's what a combustion reaction of methane produces, carbon dioxide and water. But if you write it like this, you don't have enough components to produce what you need. So what do? Well, let's look at figure 4.7. There we go. What if you put another oxygen molecule in there? Okay. So here's 1 carbon that you had, the 2 oxygens from the first oxygen molecule, and then you have the hydrogens and the 2 bubbles that you need to produce the 2 waters that you can produce. Because remember that you cannot have just atoms by themselves. They need to form something. And in this equation, you were forming carbon dioxide and water. Well, you produce 2 waters. Because that's all those bubbles, when you rearrange them, that's what they can do. You cannot have leftovers. And that's called balancing a chemical equation. 1 carbon dioxide combines with 2 molecules of water to produce 1 molecule of carbon dioxide and 2 molecules of water. So here you have the same thing, and the bubbles now have been translated into a chemical equation. We instead of making bubbles all the time, that would be very, very tedious. We don't do that. Okay, we write it in formula format. So here's your 1 molecule of carbon dioxide, the 2 molecules of oxygen you needed to produce the 1 molecule of carbon dioxide and the 2 molecules of water that you saw that you could produce. So those coefficients, the big numbers in front, are the number of molecules that you have present. 2 molecules, put a number 2 in front. 2 molecules, put a number 2. There were 3, you put a 3 here in front. It just tells you how many molecules you need and how many you're producing. Now the little subscripts, on the other hand, tells you how many atoms are inside that formula. It's part of the formula. If you change the number 2 to something else, like H2O2, that is peroxide that you use for cleaning your wounds. It's not water. You cannot drink that. That's poisonous. So by changing the subscripts, you're changing the nature of the molecule you have there. But you can tell me how many molecules you have by putting the coefficient in front. So here we go. Unbalanced chemical equations violate the law of mass conservation. Okay? You cannot do that. The law of mass conservation says the mass cannot be created or destroyed, it can only be transformed. So whatever comes in needs to come out. We need to balance our chemical reactions. How do we do that? Because a chemical reaction is just a rearrangement of atoms. That's all it is. You broke them apart and then you put them together in a new format to form new things. How do we do that? Okay, understanding the numbers in the recipe. Please make sure that you understand these. The coefficients here in red are telling you how many molecules you have of each kind. 2 molecules of hydrogen, 1 molecule of oxygen to yield or produce 2 molecules of water. The little subscripts in blue right here, okay, is part of the formula, the chemical formula for hydrogen. You cannot change that, because if you change it, you don't have hydrogen anymore. The 2 is part of the oxygen. If you change it to something else, like a 3, you don't have oxygen anymore. You have ozone. So it's part of the compound. It makes what you have there what it is. And the same thing for the water. Do not change ever the subscripts. You only can change, to balance things, you only can change the coefficients, the red parts right here. How do we do that? The first thing we need to learn before you can balance chemical equations is to determine if a chemical equation is balanced or not. So you need to count atoms. What comes in must come out. How do we do that? Look at that. Let's count them. There are two. If you read water here, that means you have 2 hydrogens and 1 oxygen. Okay. If you put it 2 in front, you have 2 of these, 2 molecules like these. So what does it mean to have 2 of these? It means that you have 4 hydrogens and you have 2 oxygens. And the way to do that quickly without having to write the 2 waters and then count 2 plus 2 and 1 plus 1 is multiplying. 2 times 2 makes the 4 hydrogens. 2 times 1 makes the 2 oxygens. So that 2 just means you have 2 molecules of water. And you could write the other one here and then count them all. So you're going to be counting atoms. And you're going to need to make sure that the number of atoms in the reactant side matches the number of atoms in the product side. How do we do that? So example 4.1, page 121. It says, determine whether or not the following equations are balanced. And they give us the equation. They have the state, so aqueous in water, solid, aqueous, solid. And this one did not give us. But usually this is gas and that's liquid, and glucose is going to be solid and this is a gas. How do we do that? Ready? Okay, let's start with the first section. 2 hydrogen chloride, and I'm not going to write aqueous because it takes space. Calcium bromide to yield 2 hydrobromides and 2 calcium chlorides. Okay, so I said to you that to make sure that something is a balance, you need to compare the number of atoms on both sides. The number of atoms coming in needs to match the number of atoms coming out of that kind, so you don't break the law of mass conservation. So what I like to do is make a line and count how many of each I have on one side and the other. So start with hydrogen. I put 2 dots. How many hydrogens do I have on the reactant side? This is the reactant and this is the product. So how many do I have in the reactant side? 2 times 1 is 2. What about chlorines? 2 times 1, I have 1. Calciums. Well, I only have a 1 because not having anything there means 1. 1 times 1, I have 1 of these as well. And for the bromide, is 1 times 2, I have 2 of these. I'll know it's a balance if it matches, those numbers match the numbers on the other side. Let's do hydrogen. So 2 times 1 is 2 with the bromide. Maybe let me put the bromide where it belongs. I'll put it together so it's easy to see. I'm going to put the bromide down here because we have the other bromide there. So 2 times 1 is 2. So far so good, this match and this match 2. What about the calcium? Calcium, 2 times 1 is 2. Uh-oh. These two do not match. Do you see that? I don't care if the chlorine is match or is not match. I already discovered that this one right here does not match. This one is not balanced. Okay? This chemical reaction is not balanced. In the next module, you're going to learn how to balance them. Right now, you just have to determine if they are balanced or not. So let's do the second section here. I'm going to write it down. So 6 molecules of carbon dioxide plus 6 molecules of water yields or produces, I don't care which word you use, a molecule of sugar and some oxygen. So who does that? That's photosynthesis. Okay, so let's balance it. And remember what I said to you, I like to just divide it in the middle and put information on both sides because I need to compare both sides. I need to compare my reactant side to my product side. And to know that it's balanced, they need to match. So let's start with the carbon. 6 times 1 is 6. Oxygen. 6 times 2 is 12. But I notice that I have oxygen right here too. So I need to add that oxygen as well. 6 times 1 is 6. So I have a total of 18 oxygens on this side of my equation. Okay, so don't forget to add the things that are the same because it's number of atoms on one side versus the number of atoms on the other side. And now I'm going to do my hydrogen is my last one. Hydrogen, the only place where I have hydrogen is here. 6 times 2 is 12. So let's do the same thing for the other side. Carbon only appears here, have 6, because 1 times 6 is 6. Hydrogen, I'm going to put it right here. It only appears right here, and 1 times 12 is 12, so far so good. What about the oxygens? Oxygens, I have 1 times 6 is 6, but then I need to add the ones right here. 6 times 2 is my 12 is 18. Everything matches. These are the same, these are the same, these are the same. This is a balanced chemical equation. And that's all you need to be able to do at this moment. You need to do stuff like this. Okay? So let's erase these and go back to instruction. And if you have questions about this, please ask. Now, let's see if I can move this out of the way. Maybe not. Okay. Remember, when you are doing balancing, because next you're going to learn how to balance. Not in this module, I don't think so. Maybe. But eventually you're going to be learning how to balance. You are going to learn how to balance chemical equations because you're going to do any more chemistry until you learn how to balance chemical equations. So you can change the coefficients, the big numbers in front of the molecules, but you cannot change the subscripts. Stop for a minute and think why. I told you a minute ago why. Stop and think, and I'll tell you. Because if you change the subscripts, you're changing the substance present. You don't have the same substance anymore if you change the subscripts. And then you don't have the same products or reactants. You have something else. Okay? So only the coefficients. When you're balancing, you only can change the coefficients. Now, let's look at this. Oh, look at this. Yeah, you do need to start learning how to balance equations. So example 4.2 on page 123, we're going to start learning how to balance equations. It says balance this equation, and then it says propane, and they give you the chemical formula of propane, reacts with oxygen to make carbon dioxide and water. And then we're going to have lots of practice. So you ready? Okay. Let's start by writing the equation they give us. So nitrogen, it's gas. I'm not going to put it for this. You don't need to put that is gas or anything like that. You don't need it for right now because you only need to know what nature of the nature of the atoms that you have present. Is yielding ammonia. So what are we doing? We need to first see what kind of atoms we have in the reactant side versus the product side. So let's start doing that just like we were doing if we were trying to find out if the equation was balanced or not. Start with nitrogen. 1 times 2 is 2. What about hydrogen? 1 times 2 is still 2. So on the other side, nitrogen. 1 times 1 is 1. And the hydrogen, you have 1 times 3 is 3. Obviously, this is not balanced. These are not the same. If you compare them, they are not the same. It's not. So how can we make them the same? How can we change a 1 into a 2? What can I do? Well, if I multiply this by 2, I'll get my 2. How can I do that over here? I cannot change the subscript. The only thing I can do is put a new coefficient in front. 2 times 1 is the 2. And now those two match. What happened to the hydrogen when I did this? What happened to the hydrogen? Well, 2, let's take this out. 2 times 3, 2 times 3 is 6. I have 6 hydrogens on this side. That is not a 2. Let me erase this because now it's the same. Okay, they match. I'm gonna put they are equal. So that's good. But these two don't match. We have a 6 and a 2. How do I make a 2 into a 6? I can multiply it by 3, and then I'll have a 6. Where can I do that? Well, I can change my coefficient. If I put 3 times 2, I get my 6. And now they're equal. This right here is a balanced chemical equation. And that's how you balance equations. You count the atoms. When you find something that doesn't match, you think, how can I make it match? Well, if I multiply by a certain number, then they're going to match. But then if I do that, something else has changed. Change it. And then how do I go from the new one to the one I had before? Well, I had to multiply by 3. And it's trial and error. Trial and error. This right now, no other way to do that. Let's look at another example. We have propane, and they give us the chemical formula for propane. So 3 carbons and 8 hydrogens, and it reacts with oxygen. The tricky part here was for you to remember that oxygen is a diatomic, so it needs to come in groups of 2. You're learning this. Remember, I said memorize them, those that come in groups of 2, because when you write chemical equations and say oxygen, you need to put that 2 in there. And it says it produces or it yields carbon dioxide, which is CO2, plus water. And you have learned the chemical formulas for those already. So we have this, and now we need to balance it. So divide it into the 2 sections and count the atoms. Start with carbon. So reactant versus products. What comes in must come out. They need to match. It needs to be exactly the same number. So how do we do that? That's math. So 1 times 3 equals 3. For hydrogen, 1 times 8, I'm going to put it here, but you can do it directly, 8. Oxygen, 1 times 2 equals 2. Let's count the carbons on the other side. Carbon, 1 times 1 equals 1. That's going to be a problem. Hope you see. Let's do the oxygens next. Oxygen, 1 times 2, it's 2. That matches. Except that, look here, there's another 1. Plus 1 equals 3. Now it doesn't match anymore. So do not forget to count them all. There were oxygens here and there were oxygens here. They all belong in the product side. So these are the oxygens in the product side. Go back to the green here and let's do the hydrogen. So the hydrogen here is 1 times 2 and no more. Let's do, and that doesn't match either. They don't match. So how do we make them match? Usually what I do is leave the ones that are by themselves for last. Okay, because it's easier to give them coefficients at the end. So I will not start with something that is by itself. I will leave that for last. That's a good trick to use. I would start with a carbon, for example. I'm going to use blue. How do I go from this 1 into a 3? I know I can multiply by 3 and I'll have my 3, and these will match. Remember that I cannot change the subscripts, I only can change the coefficients. So if I put a 3 here, now I have the 3 carbons. But what happened to the oxygen if I did this? Okay, so this is now wrong. 3 times 2 3 times 2 equals 6. And now you still have to add that 1. You have 7, okay? But we're going to leave that oxygen for last, so we're not going to be too concerned right now. How do we go from this 2 into an 8? Well, I can multiply it by a 4. That's going to be 8. This has to be in the form of a coefficient. So I have 2 here. I need to end with 8 because I want 8. If I put a 4 in front, 4 times 2 is going to give me that 8, and 8 is done. Okay? But my oxygens are not done. I'm not done. When I put that 4 here, what happened to the oxygen? It changed again, so this is still wrong. Okay, let's keep working on the oxygens. I said to you, leave the oxygens for last because it was by itself here, so it's easier to modify at the end. So this is wrong again. And you can wait if you want to until you have the first 2 done. But 3 times 2 from the first carbon dioxide, that's 6. And then you're adding the 4 times 1, okay, 4 times 1, which is 4. You have 10. You want your 2 to become a 10. This 2 needs to become a 10. And you only can change the coefficients. If I put a 5 here, now this becomes 2 times 5, a 10. And they match again, and I'm done. This is my balance equation. One molecule of my, what did we call it that? Propane reacts with 5 molecules of oxygen to produce or yield 3 molecules of carbon dioxide and 4 molecules of water. It's tedious. This is tedious. It's not complicated math because you're multiplying, okay, or dividing to find out how you can find the 10. But you need to keep balancing both sides until they match. That's the game. It's making them match. So let's start now doing some of your extra practice problems. You can find them on page 572. You're going to practice how to do this. I'll give you the balanced chemical equation, and if you don't get it, then see how it's done. This is the last slide, really. This is just a review of what we did before, but that's not what I wanted to do. I wanted to go here. So, okay, for number 5, because they're asking you to balance all those equations, if for number 5 you got this, then you are done. I'm going to put it right here, number 5. If not, check to see how I did it. But you should be getting 2 of hydrochloric acid in a coarse solution, if you want to put that. Calcium in solid solution to yield. Calcium chloride plus hydrogen. So 2, 1, 1, and the 1 here. If you didn't get this, let's see how this is done. If not, move on. If you got it, just move on. So they give you these. That's what they said. This is what they give you. I said to you, start counting atoms on both sides, reactant and product, and compare them. So hydrogen, 1 times 1 is 1. Chloride is 1 times 1, 1. Calcium, 1 times 1 is 1. Calcium here is 1 times 1, 1. I should have put it, you need to be systematic and try to put it where it belongs so you can compare it better. Calcium right here. Okay, 1 times 1 is 1. Chloride, I'm going to put it right here. 1 times 2 is 2. That's going to be a problem. And the hydrogen, it's 1 times 2 is 2 is going to be a problem. So here we have problems right here and right here. But how do you make 1 transform into a 2? Well, if I put a 2 here, that becomes 2 times 1. That becomes the 2 that I need, and now they are equal. If I do that, my chlorine also is changing. Sorry, this was correct. I said chlorine, but I took the calcium. So this now becomes 2 times 1, the 2, which we needed. And that's what you needed, the 2, which is right here. So that one is done. For number 6, if when you try to balance this equation, you got 2 of each, 2 hydropromides plus 2 sodiums to yield 2 sodium bromides and actually 1 hydrogen molecule. This is what you got, you did it right. What if you didn't get this? You can try again or check to see how this is done. It's all about counting atoms. So hydrogen bromide like this is what they gave you. It was not balanced. And the hydrogen. So break it into 2 sections. Okay. Start counting atoms. Hydrogen 1 times 1, 1. The bromide 1 times 1, 1. Sodium 1 times 1, 1. Sodium, let's put it here. Sodium 1 times 1, 1. The bromide 1 times 1, 1. And the hydrogen 1 times 2, 2. So the only one that did not match was the hydrogen. That was a problem. So what do? To make this 1 into a 2, we can multiply by 2 right here because we don't have hydrogen anywhere else. The problem now, this has become a 2. The problem is that we have changed the bromide as well. We don't have 1 anymore, we have 2 of these. So I need to change my 1 now into a 2. You see that? So I can put a 2 here to change my bromide. This has become 2. But when I do that, now my sodium has changed as well. This has become a 2. 2 times 1, 2. So now I need to go to the other side to make my 1 into a 2. And if I put a 2 here, now this has become a 2. And this is where it came from. Okay? So just keep counting atoms, both sides, until it matches. Number 7. It's number 7. Let's see, I have it in front of me. Here. 2 silver chloride plus zinc to produce zinc chloride plus 2 silver. Okay, if you found this, you did it right. If not, try again or check to see how it's done. So for 7, they give you this equation. And silver. Silver. Okay. Remember to divide everything. Start counting atoms on both sides. So 1 times 1, 1. 1 times 1, 1. And the last one for the zinc. 1 times 1, 1. The zinc goes right here, so you can compare it easily later. 1 times 1, 1. The chlorine is right here, so 1 times 2, 2. And the silver. I keep putting aluminum. What's wrong with me? Silver. Okay. 1 times 1, 1. So let's see. This matches. This matches and this matches, but the chlorine does not match right here. We can make the 1 into a 2 if I put a 2 here. Everybody sees that? Now this has become a 2. 2 times 1 is 2. But when I did that, I changed my silver as well. Now this has become a 2. So I need to change the side to match. If I put a 2 here, now the silver is 2. And this one didn't need any changes. And that's the same as this thing on the top. 8. So we're moving on to 8. We copy what you should be getting. 8. Magnesium chloride plus hydrogen sulfide. Magnesium sulfide plus 2 hydrochloric. Okay, so there you go. This is what you should be getting. This 2 is what you needed to find. let's copy what they gave you. If you did it right, move to number 9. But if not, try again or check to see how I did this. It's always done the same way, and some of them are going to be harder than others. These are pretty easy right this minute. They're going to get harder. That's why you have to be really good at the easy ones right now, and you're going to have a chance to practice quite a bit this week because they're going to get harder. So divide everything in half and start counting. Magnesium, 1 times 1, 1. Chlorine, 1 times 2, 2. Hydrogen, 1 times 2, 2. This is bothering me, I'm sorry. Okay, this is a 2. And the sulfur, 1 times 1, 1. So magnesium right here, 1 times 1, 1. Sulfur right here, 1 times 1, 1. Hydrogen, 1 times 1, 1. And chlorine, 1 times 1, 1. So what's going on here? This seems to be matching, and this one seems to be matching. The other two do not. So what can we do? How do I make my chlorines match? Well, if I can multiply this one by 2, I'll have a match, and it's right here. So 2 times 1 is my 2 that I needed. If I do that, I'm also changing the hydrogen. Okay, so now here I have the 2 that I needed. So now they're equal. I'm done. That's all I needed to do. Okay. So number 9, moving on. Sorry, yellow for the answer first. So 9, if you got 1 molecule of this carbon compound plus 8 oxygens to produce 5 carbon dioxides and 6 molecules of water. We did right. How did we do this? If you didn't do it right, try again or check to see how it's done. You start with a compound, carbon compound, plus the oxygen to give you the carbon dioxide, plus water. It's always good to leave a tiny bit of space so you can put those coefficients in front. Always a good idea to write them with a space. So let's start counting the atoms. Carbon, 1 times 5, 5. Hydrogen, 1 times 12, 12. Oxygen, 1 times 2, 2. Carbon right here. There's no more carbon, so 1 times 1, 1. Oxygen. There's going to be oxygen here and here, so we're going to have to add them up. 1 times 2, 2, plus 1 is 3. And my hydrogen I'm going to put here so I can match them. 2 times 1, 2. Well, as you can see, nothing is matching. How can we match? I said to leave the oxygen alone for right now. Leave that alone because it's by itself, so it's easy to modify at the end. So with the carbon, if I multiply this by 5, I'll have my 5. I can put my coefficient right here to modify because that's all I can do is change them, the coefficients. That's all I can do. So now I have my 5. We'll count the oxygens at the end, so we know this is going to be wrong. Let's do the hydrogens next. How do I go from 2 to 12? Well, I need to multiply this by 6. It's going to be my 12. But as I can see, it comes in groups of 2. 12 divided by 2 is 6. 6 times 2 is that 12 that I need. Okay, so think about it. You need 12, but they were already, you're going to have to be multiples of 2. That's a 6 right there. So now I have the 12 and the 12. This is equal. This is equal. We're fine. Let's count the oxygens because we change all the oxygens right here. I'm going to put it in red. So 5 times 2 is 10 plus 6 times 1 is 6. I have 16 oxygens. Because this by itself is going to be easy to change my 2 into 16 by putting an 8 right here. Because 8 times 2 is 16. And now it's balanced, which is what we wanted. And this one is done as well. The last one, oh, number should be yellow, number 10. looks like this. 18 carbon dioxides plus 16 waters yields 1 molecule of this carbon compound. Has a lot of carbons, lots of hydrogens, some kind of sugar on 16, and 18 oxygens. Okay, and this is not what they give us. So if you didn't get this and you had a hard time with it, let's check to see how it's done. So they gave you this. I'm just copying what they give us. Because remember, the subscripts never change. The only thing that can change is the coefficients in front. And I didn't leave a lot of room here. Well, again, there's a tiny bit of my nozzles, so I can make a tiny bit more room. Okay, so start counting. Start counting. That's how you start. Carbon, 1 times 1, 1. Oxygens, well, they're here and here, so don't forget to add them. 1 times 2, 2, plus 1 is 3. Hydrogens, 1 times 2, 2. Carbon here, 18. 1 times 18 is 18. The hydrogens, I'm going to put them right here, is 32. And the oxygens, add them up. So 16 plus 2 is not 18. Nothing matches. Nothing. So let's start trying to make things match. Leave the oxygen for last, because I said to you that's the easiest thing to do. You can try a different way if you want to, but that's something I learned when I was learning this, is just leave those that are by themselves until last, because it's easier. So how do I go from 1 to 18? Well, if I put an 18 here, now I have 18 carbons here, and this matches. Great, very good. Leave the oxygen alone. Let's do the hydrogens. I want to have 32, and I have 2. The coming groups of 2. So 32 divided by 2 is my 16. That's right here. Okay, that now is 32, and now it matches. Because I changed my coefficients, I have changed the number of oxygens I have here. So 18 times 2 is 36. 16 times 16 times 1 is plus 16. So we need to add them all up. 6, 12, 1, 3, 4, 5. I have 52 oxygens I need to match here. Okay. Well, I already know that I have 18. So how do I get to 52, but in groups of 2? So from 18 to 52, there's a difference of what? Use your calculator and find out. Okay, yes, we're doing it correctly. So the difference is 36. In groups of 2, if you divide 36 by 2, you're going to get that 18 that you need here. So there you go. Remember that if you start changing the coefficients in here, you would change the carbons and the hydrogen, and then you would have to start all over by changing things right here. So leave the oxygen for last, keep those 16, and then check to see how many you have on the other side. Find the difference, and then divide by 2 so you know how many of those molecules you need, because they come in groups of 2, and then you're done. So this completes balancing equations for this module, but this is not done. You're going to be doing this for a while. And let's go back to this slide I showed you a minute ago, but this is just the same thing we have learned. I said study, study, study. You need to know this. This is the end of the second half. You're going to read your textbook, add to your notes if you need to, review examples if you need to, work through all on your own as you encounter them, and you're going to have a lot of things to balance. So you're going to be counting a lot of atoms. Correct them as you go. Study for your weekly quiz. Do any labs assigned for this section, if you have any. I mean, I just read it, but you know if you have assigned things or not. Do the review questions and self-correct by using the solutions manual. Do the practice problem, self-correct by using the answers key first. If that doesn't help, then use the solutions manual. And if that still doesn't help, ask me. So I hope your week goes well. Bye-bye.